Glasses on. All right. Good morning, everybody. Morning, Brooksy. Who else is here? View. Morning, Vince. Morning, Cappy. Kevin, good morning. Got you this time. Okay, so we are on lab 14. So I'll just show you where I'm at, and then I'm going to do some wiring to give you time if you need it or want it to get set up. So I have downloaded all the files for this lab. I also grabbed the diagram, even though I don't really need it here because I'll get it on the web. We have a macros file again, so we're going to be separating out some of the coding into a separate file. That's because the macros, like functions, just help organize things a little bit better, and it's easier to focus in on smaller parts of the problem. Still have a main and then the config files. Okay, so let me go pull up the diagram. So this is a familiar picture. This one is the same circuit as before, except for the three-legged LED goes away. So mine's completely unwired, and I'm just doing this to slow myself down and give you some time to get warmed up. But I left everything else intact because it's the same 8-bit display by LED. So I'm going to wire it up according to the diagram. What this lab is supposed to do, by the way, so we're going to just sort of randomly, meaning we're just going to make up some values and put them inside of an array so that we can practice coding in assembly with arrays, and then we're going to use the button to cycle the display through the values in the array. So what should happen is it will start by displaying the first value in 8-bit binary, and then every time we click the button it'll go to the next value and the next value until it gets to the end of the array, at which point it should wrap back around to the beginning. So that's what we want the program to do. Alright, so here's your warm-up, and my warm-up is that I'm going to wire my breadboard to the Nucleo board. And I'm just going to, since the wires are all kind of hairy, I'm just going to be careful about this again. I did go through and just make sure everything's still seated. Since this has been built this way for a while, I just want to make sure everything. So I went ahead and did that already. But now I'm just going to work my way down the list. So this first one down here is D6. I'll turn it this way so I can see D6. This second one goes to D14. The third one, D15. You may have this already wired, so you might just be waiting for me for a second. But you could be downloading source files or whatever it is that you want or need to do. D8 is right here. D7. Wait. Yeah, D7. D11. So I'm working from right to left. D11. And then the last two, this one is D12. And then this one over here is D13. Okay, so there's me on the board, and I need to connect ground. And I haven't powered it yet, so I still have a loose USB cable. I'll power it when we get some code, but I am going to hook up this end to the USB cable. But I'm not going to connect it to power until I've got some coding to try out. Okay, so in the code there is a new thing that I'm going to show you how to do, and then we'll work through some homework questions that give us a little bit more detail. So that's kind of the same routine we've been following. You kind of get a soft introduction and coding to a technique, and then we sort of explore the concept a little bit in a little bit greater detail after you've seen it in code through homework questions. Okay, just checking my setup. I think we're all good. Okay, so I'm going to hide my browser and start looking at the code. So I'm going to start in main.s, and I'm just going to work down until I am forced to move over to macros.s. So right off the bat, I encounter number 1 here, which is to declare an array called numbers of 40 bytes, which is 10 integers worth. So 10 integers, 4 bytes, or 32 bits per integer, that's 40 bytes. So we did that before, which basically, by the way, this is just a label if you think about it. Just like a branching label, an array name is basically just it's a location, which in this case doesn't arrive at instructions, it arrives at data. So we're in the data section, by the way, so we're actually working in RAM. Probably you remember how to do this. We're going to skip 40 bytes. I can also do fill with a comma and what I want to fill those 40 bytes with, but if I leave the comma and the fill off, then it's going to get filled with zeros anyway. Why did I call it len here and not length? I don't know. Let's call it length. It's not going to matter, except for I notice there's a reference lower down the page. So hopefully you remember this is from Tuesday. All we're doing is setting aside 40 bytes of memory, and then we have to write code to index that like an array. The second one says add a label. I'm going to call it length. I don't know why I had len in there. Why not just use the full word? That's not that hard to type. So length. So this one is going to feel a little bit funny at first, but I'll try to explain it, and then hopefully it makes some kind of sense. So these things with colons are labels. They're really just locations in code. So this label numbers gets me to where there are 40 bytes in memory, which is effectively this label numbers then gets me to an array of integers we're going to use it for. So labels are really just addresses, which means that this is the address of a 40 byte array, or a 10 integer array if you want to look at it that way. So this length label is also an address, and because there's nothing but these 40 bytes between numbers and length is basically the next address in the program. I'm going to move it for a second because it might make more sense to you if I put it here. Length is the next thing after these 40 bytes are over. So one way to look at what length is that it's actually the address that comes after the array. And another way to say that is if I have the address that comes after the array, I actually have a means of knowing when I'm at the end of the array. So length will give me the ability in code to detect when I've gone past the end of the array, because I will arrive at length, which is kind of cool. I will arrive at this address in the program, which is the address that comes after this array. So it's weird, but we don't. There are other ways to do it, but we're going to do it this way on this lab. We're going to use this address in code to detect when we've gone past those 40 bytes. So in other words, this is the end of the array. But it doesn't matter if there's white space in between, so having a blank line doesn't change that. This is still the next address after this ends. So that's what that's about. Hey, where's Daisuke? Daisuke not here. Oh no, now he's here. Daisuke is usually in the good morning group, so good morning, Daisuke, even though you didn't chat it. Okay, so hopefully that made some kind of sense. This is the array. This is marking the end of the array so that we can detect it in code when we reach the end of the array. All right, that's the first two elements. It used to say len. So again, just sort of make note of this if you're watching the video later. I changed that to the full word length because I decided that that was just pointlessly lazy. Good morning, Daisuke. Glad you're here. So hopefully that makes sense. That's the end of the array as we would mark it in assembly language with an address. Okay, let's scroll down then. So we're using, oh, we have to have C here because that's what the blue button's connected to. I will note as we're scrolling past it that, do we have an include? We do. All right, so hopefully your Atom editor is not screwing this up. But if the colors are all wrong, you might check this include and maybe temporarily comment it out. My colors are all looking okay, and I think you guys took updates on Tuesday that fixed this. The updates for Atom, by the way, at the bottom right corner, I wish I had a better way to point at it, but at the bottom right corner of the Atom editor, if there are updates, there'll be a little blue link down there that says you can take updates, and I recommend that you do. Okay, so anyway, as we're scrolling by, I'll just note that there's a macro here for initializing RAM. So there's a call to a macro, and if we look at macros.s, we'll see that that one's already been implemented. So we don't have to touch that, that's already done, but just to kind of clean up the code in main, I offloaded the RAM initialization into the macros file. So we don't want to touch that, but that's where that went. Okay, so just keep going. All the config has been done for me, so that's nice. That gets pretty repetitive anyway, so good that that's already done. I'm looking for number 3. All right, so here's number 3. So what I'm going to do, I think, is whenever it tells me to call a macro, I'm going to go ahead and do that. And then I'm going to go implement that macro, and then I'm going to try to compile what I've done up to that point. So number 3 says call the reset array macro. And then I'm going to flip over to the macros file and I'm going to implement that thing. Oh, and by the way, don't be shy in chat about saying please pause for a second or please wait, or if you need me to hit my pause button on myself for a sec, just let me know and I'm happy to do it. Or if you need me to scroll back and show something on the screen, because there's a fair amount of code going on in this one. Okay, the reset array macro, this is how you call it in assembly. It has no arguments, so we just put the name of the macro in here. Then I'm going to go and implement it. So it's the first macro. Oh, it's not. There's a delay macro. Why didn't I just leave that with code in it? Well, whatever. Let's do reset array. So it says something about the stack, and I'm going to show you how to do that part. But what I want to do is populate the array. So we could do this however we want. I'm going to do it with the, let's use the non-updating indexing. Let's use the non-updating indexing way of doing this. And I'll remind you what that looks like. We practiced it a little bit in the homework on Tuesday. So what we want to do here, it says random-ish. Turns out that getting random numbers on our nuclear board is a lot of work. So we're just going to pretend. Um, I'm not going to do crazy randomness at first. I'll go back and fix that later, but let's do the setup. So if you don't, I'm reminding you, we're going to get the address. I'll put it in R0. It doesn't really matter. So there's the start of my array. And then to get data into the array takes two steps. The first step is to put a value in a register. I'm going to do, let's say I have 10 integers. We don't want to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because, well, do we? Yeah, why not? That's not going to, is it going to hurt anybody? Probably not. Let's just do it that way. Let's just load it up with 1 through 10 to start. So we get the address of the array. Then we're going to use R1 as the middleman to store values, and then I'm going to take that R1 and I'm going to put it into my array. And we can if we want to. The non-updating indexing means that I do a byte offset here, so I can do a 0 byte offset. That probably, by the way, works without the pound sign, but to me it's a little bit easier to see when I'm doing array indexing if I put a pound sign on it. And then we're about to repeat that a whole bunch of times. But before we do, let's go try to compile it. Well, assemble it. So I'm going to bring up my browser just to show you what it is that I'm doing. So I'm just going and I'm getting this first step, the compile step. I'm going to copy that and then I'm going to paste it into my terminal. I just want to make sure that I'm compiling right now. So that's what we want. Nothing happening, that means we're all good. So make sure yours is, and if it's not, let's fix it right now before we get too far. Okay, so I'm going to hide my browser. So we're just going to use that compile step on every once in a while just to make sure we're still good. So there is the value 1 at index 0. Now we're going to put the value 2, so we need a middleman for this. I'm going to put the value 2, the next one over, pardon me. And I'll just quiz us while we go. So what's the offset here that I want? Don't be shy. Outstanding, 4. So remember, we're offsetting in bytes. So we need to move over 1 integer's worth, which on ARM is 32 bits or 4 bytes. So this gets us, in C++, this would be index 1 because C++ automatically computes the bytes for us. Anyway, so now I'm going to start going a little faster on this part. So I'm just going to load up 1 through 10. 8 to get to the next one. So this is non-updating, and what we mean by that is that the R0 never moves away from the front of the array. We just use the byte offsets to get into the array to the location that we want. And notice that at every stage I'm moving over an additional 4 bytes or 1 integer's worth. 5. If you want to copy and paste and go fast, you can. I'm going to type it and try to paste myself. So there's 1 through 5, 5 more to go. It's 20 bytes over. which is index 5 as we'd write it in C++. So the R1 again is just the value that I'm storing into the array, but to be able to do a store instruction I have to get the values into registers first. So I have to load up the value that I want into a middleman register, and then I can store that value from the middleman register into the array in memory. Where are we at? 24 bytes over. We're at 28. And I'm going to go later and change the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to a greater variety of values just to test it out. But for now, let's just do 1 through 10 so that when we get to the testing part, we know what's going to come out. 10. And I'm using decimals here. Oh, I did a move where it should have been a store. Yeah, thanks, Vince. You caught that quick. And I'm glad you did, because someone watching the video later is going to put a move there. So stopping and pointing out. Vince caught it. I put a move where there should have been a store. So we have a 40 byte array, and if I offset to 36 and use an integer's worth, that's the last 4 bytes. So that's the whole routine except for one new technique. Okay, so don't worry about the terminology for it. Why am I clearing my throat in your ears? I don't know. Sorry. Okay, so you may or may not remember, but when we call a macro, all we're really doing is copying and pasting this code. All that really does is copy and paste that whole chunk of code into main. And that can be a problem if in main R0 and R1 matter, because we're overwriting them with new data constantly. So there's a technique we can use in assembly to more or less make these registers act like local variables. So think of it that way for now. I want to, like I would in a high-level language, protect my local variables, or at least protect the rest of the program when I use variables. And the way to do that in assembly, I'm going to put it up by this comment here, is by using a data structure called a stack. And we're going to talk about what a stack is next time. But this instruction, push R0, and the dash means through R1. So I could do through more registers, but I only use R0 through R1. So that's the only ones I'm going to push. What this does is this protects those two registers, protects the rest of the program from my use of those registers. So it's going to basically copy the current values of R0 when we get to my macro, and then I'm just going to wreak havoc all over them. But at the end, when I'm done, right above my .endm, I can pop them back out and restore them to what they were before I started messing them up. It's hard for me to get all of that on the screen at once. But the last thing is a pop of those same things that I pushed. And right at the very first in the macro, I did a push. The registers that I pushed were the two registers that I am using. And that is a use of the stack where I am pushing to preserve and popping to restore the values in those registers before and after my macro overwrites them. I hope that makes sense. We're going to do that a whole bunch, and then on Tuesday we'll talk about what's actually going on. So when this says use the stack to preserve and restore any registers used, well, I used R0 and R1, so that's what that means. Push those two things and then pop those two things when I'm done. If you've been that far in P and A2, then you may have heard about a stack. That's what we're using actually. It's built in. Okay, I'm going to save and I'm going to go do a compile real quick. Make sure that if I made any mistakes, I catch them early. So for me, I'm all good. If you have a mistake, let's bring it up now and make sure it gets cleaned up before we get too far. Okay, so the macro is called reset array, but all we really did is populate it with values of our choosing. I chose 1 through 10 to start so that when I test, I know what to expect. Okay, back to main. That was number 3, reset array. Okay, 4A and 4B. Load the address of the array into a register. We just did that. But think like programming in a high level language where you're using functions. So, except for you have a lot more globals. Pop R0 and pop R1. Oh, okay. Let me go back a step. So the character in between the R0 and the R1 is a dash or a minus sign. Okay, so I know we just did this, but the instructions tell me to do it again, so I will just do it. Sure. Load the first value of the array into a register. Okay. Guess I'm going to do that. So I'm going to load the first value of the array. And since R0, so remember I can, if I want to, do a 0 byte offset, but that's optional. So anyway, I'm doing a load, not a store, because I want to go to that address, offset 0 bytes, and grab 32 bits, which is the first integer. So now the first value in the array is in R1. But technically, when you're doing a 0 byte offset, it's the same thing to not do any offset, because 0 doesn't have any effect, but it can be easier to read, and it can be easier when you're scanning through your code to draw your attention to the fact that I'm loading a value from an array here. So the address of the array goes in R0, and then I dereference that address. I offset 0 bytes, which is the 0 index, and I take that value into R1. Alright, so that's what's happening there. Okay. Number 5. Call the showBits macro and pass the register containing the value to be displayed. So it's called showBits. I guess it's all small. Now why did I do it that way? I don't know. Is it all small? Sure is. Okay. Anyway, on a showBits, and then I'm passing an argument. And in ARM assembly, that's how you do it. So the value I want to show is in R1, which right now is the first value in the array. And then I'm going to go work on showBits. So what this is supposed to do is it's supposed to take the value that's living in R1. Okay, yeah, perfect. So R1 will be the value parameter. And then showBits. I'm irritated with myself because I used a capital A on array and not showBits. But whatever, that's how I did it. So I'll just roll with it. So anyway, R1 becomes the value to show. Okay. So here we go. Showbits macro. Showbits. Okay, so we've done this before. I'm going to quickly go grab. I'm going to rewrite the code. I'm just going to grab notes for myself from the last lab. because it had the proper mappings, didn't it? Yeah, let me grab these mappings. Nope. So that you have a reference to it. So that's, and then we're also going to have these bits. All right, so I brought these over just so I remember what's what. 5, A6, A7, A8, A9, and I think that the way that we've done this before is this is the 2 to the 0 bit. This is 2 to the first, and so on. To the first, 2 squared. We've written this code a few times now. 2 cubed, 2 to the fourth. I don't need the turn on note. I just need the reference point to remind myself what each LED means. This one will be 2 to the fifth bit if that's enabled, 2 to the sixth, and 2 to the seventh. That's just so that we know what I'm talking about. Okay. I'm going to do the stack part later. Okay, so this one we have to do more of the work for ourselves because we need to get the output data registers and then manipulate those values. So I'm going to do the A bits first. So I'll just use this and I will get the GPIO A output data register that popped up for me in Atom. That's where I need to do some enabling with ORs based on my bits, and then I'm going to load up the value into R1. So that's the current value of the A outputs. I'm going to do the stack part later. Now the other thing that I should have done, which I'm going to do right here, I'm going to move, let's use like R5. Why R5? Just because I felt like it. Alright, so first time we've done this, but to reference a parameter inside of an ARM macro, ARM assembly macro, you use the backslash. So that's the backslash. So whatever that value is, that's how I grab a reference to it. And since from the view of the macro I don't really know where or what that value is, I'm just going to copy it into R5, and then I'll use R5 as my testing value. So R5 will contain the value to be displayed. Hopefully that makes sense. Alright, I should have done that first, but I just went back and did it. So that's the value to displayed. It came in as a parameter. So I'm just going to take the parameter and I'm going to copy that value into a register and then use that register. So R5 now contains some 8-bit integer value that I want to display. And now we're going to do the old familiar test all the 8 bits in R5. So I'm going to test R5 at 2 to the 0. And the bit testing is the backward one. So if then not equal, I'm going to OR not equal. I need to move these over to make it look pretty. R1. And that's the wait, 1, 2, 3, 4, 5, 6, 7, 8, and I need A to the 5th, right? So 2 to the 0. That's 2 to the 4th, 2 to the 5th. So this is my hex value. We've done this a whole bunch of times, so sorry to keep walking you through it, but just make it. So why R1? Because that's the A outputs that I need to manipulate. So R5 is the value, and if that bit in R5, my value is on, then I need to turn on this bit in A so that my LED comes on. So R5 is the value, R1 is the display right now. And I'm just going to work my way through the 5. So that was A5 is the 2 to the 0 bit. Then I'm going to test the 2 to the first bit. And that's A6. So my O-ring value is 40. If you see me make a mistake, please call me out for it. I'm going to try to not waste too much of your time on this same thing that I think this is probably like the 4th time we've done this. But maybe it's been helpful for people to get it. This is the 2 squared bit. I'm going to do one thing different here coming up just because I feel like it. So this is the, what am I on, A8, A5, 6, I'm on A7. That's this one. Same stuff. If you want to copy it from your earlier code, you could totally do that. It would make this be a lot less painful for you. That's 2 cubed, so now I'm on 2 to the 4th, which is, no, wait a second, I have these wrong. 2 to the 0, 2 to the 1st, 2 squared, 2 cubed. I'm on 2 cubed. And 2 cubed maps to A8. Which is this one. So the O-ring value to get the right LED to come on is 100. Alright, now I am on 2 to the 4th, my last A. So 2 to the 4th, which is that one. That goes to A9. So none of these. This is 8, then A9. So that is 200. Alright, so that was all the A's. So I'm going to store that value back into A. So now I've manipulated that. I'm going to put it back. A is done. It's going to be pretty obvious because this code's going to be there. All right, so now I'm on the B part, which is the upper 3 bits of my value. So let's get, so the one thing I'm going to do different is I'm just going to reuse registers here. So GPIOB, output data register. I'm just going to reuse R0 for B because I'm done with A. So I can just do some reusing. And I'm going to reuse R1 for B because again I already manipulated and stored the A settings back. So now I can reuse these registers. Alright, last three. So R5, I am testing, what am I on now? I'm on 2 to the 5th, which is 34, I think it's this, 2 to the 5th. So if you're watching a video later, just pay close attention to what I've done here because I'm reusing registers, which we have not done it this way before. So at this point, R1 is referring to the B pins, the B LEDs, because I made that switch up here. this is what, B8. B8. So B8 is this one right here. So that's 100. Now I'm at 2 to the 6th, right? Yeah, 2 to the 6th, which is 3, 4, 5, 6, which is 40. That one is on B9. So this is 8, 9. So that's 200. And then the last one, which is 2 to the 7th. 2 to the 7th is 80. And I'm kind of relying heavily on the fact that you kind of know your way around these things, so I can go a little faster. Hopefully that's true. I'm on B10. That's 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th. And then I'm going to store those to make those settings take. And then I'm mostly done. So we've done that whole display before, the exact same setup, except for this time I made a change and I reused some registers. In the past we've used different registers. This time I reused some. Okay, so hopefully that's the correct display. The other thing I need to do is I need to preserve registers. So I did something a little different on purpose to show it to you. So I use a push. When you have registers that are in a sequence, that's R0, not RO, you can use the dash. But if you have a register that's out of sequence, you can use a comma. So R0 through R1 plus R5 is what I need to preserve, because those are the registers that I messed with here. So I could have used R2 here and just done R0 dash R2. This was one of the biggest pain in the rear parts to implement, so hopefully we're going to do good on time. And then probably you all know what comes at the end. Need to do something right here related to that stack thing. So preserve is push, restore is pop. Nice. And then we pop the same things that we pushed. So R0 through R1 plus R and R5. It probably wouldn't hurt anything, by the way, to do R0 through R5, but why do the work when those are the only registers that we used? So that restores those registers back to whatever they were before my macro started pooping on them. Let's do a compile real quick. Make sure we're still getting 0 errors. Okay. I keep doing this, and then I'd already hit entered. So this is before I hit enter, and this is after I see no mistakes. So I get a this. Hopefully you get a this as well. No mistakes. But say in chat if you are seeing any compiler errors. If you get something other than nothing, then let's get that fixed. By the way, if you're able to follow along, then you've done a good job in this class. Like that kicks ass. Show this to your average programmer and see how much sense they can make of it. That is not readable stuff unless you have some experience. So that's pretty cool. All right, there is show bits. what happens next? Should we just keep going? I think maybe we should just keep going and see what happens. Um, yeah, let's just go all the way. So there's number 5. Now there's a whole bunch of, so you may recognize this is the button code. So we don't have to touch it, but the button code's there to detect when the blue button's been pressed. Okay, here we go. Number 6. So if R6 is 1, then we'll advance to the next item in the array. So if R6 is 1, it says 0x1, but you all know that I can just write that as decimal if I want. And then I'm going to use an if-then block because this is the most elegant way to do it in my opinion. Advance to the next item in the array. Let me have a look and see how that's happening. Main loop. Aha, okay. Except for I'm kind of unhappy about what's going on here. Let me think for a second. R6 is 1, advance to the next item in the array. How is it going to know to do that? Oh, okay. So this one's tricky. Main loop. Yep. Okay, so if we go back and look at the main loop, the item in the array that's being displayed is in R1. So what this means is if the button has been pressed, R6 is 1, I need R1 to get a different value, I would assume. I don't know what this could possibly help. Branch main loop, but what does that possibly matter? I think we're not going to need number 7, but we'll find out. Okay, so if the button's been pressed, we need R1 to get a different value. That's what we got to do here. So this may not be the best way to do this. If then, well, let's just see. How many operations do we need? We have some options here. How would I handle this? Load the address, load the first value. Let's just see if we can make it work. We need the address. Yeah, I'm not happy with the way we've set this up. We need R1 to move over 1, but it would be super handy like load the address, load the first value, call show bits, use the flag. You're seeing me sort of struggle with my own setup here. Let me put this back. I did Control Z to put that back so I can think on it for a second. Pass the register containing the array value to be displayed. So what we need to do, somehow we need to keep track of where we are in the array at the same time. So we need to know where we're at in the array and advance to the next item in the array, but my setup seems funny. I may have to change my setup. Okay, here's what I want to do. We're going to need to know where we're at. We need to know where we're at. This R0. Set the array the first value. What else? I could have reset to base address. What do you mean? Load the next. Okay, there it is. That was the one that I was worried about. Okay, so let's do it this way. Let's find a register that nobody's touching anywhere in here. R0 is being touched. R1's being touched, R6 is being touched. So let's change line 115 and let's use R2 for the array. Now we're going to have to keep that in mind because we're going to make sure that R2 always means the array. Kind of like a global. Okay, so R2 is going to be where we're at in the array, which initially is at the 0 spot. So R2, 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 R2. So every time the button is pressed, we need to move R2 over by 1 integer. So we're going to use updating indexing here in main and non-updating index in our macro. So if you follow that mess of my thinking, if the button is pressed, then we need to move our array pointer to the next integer in the array. So the question then is, what value do we adjust the array pointer by to get to the next integer over? Probably everyone's all confused because of the mess that I just went through in my head. Sorry about that. But R2 is a pointer to the array, and we're just going to know that that's always going to be the case in our program. So this code means, that's right, 4. Nice. So we're going to move the, yes, correct, Brooksy and Vince. So we're going to move it over 4, which moves it over 4 bytes, which moves it over to the next position in the array. So that's what updating in. So in here in main, we're going to use R2 with updating indexing to advance through the array and get values. Okay, so sorry about that. Now hopefully we're back on track. Okay, so now we need to detect if R2 went too far. And the way we're going to do that is we're going to use, let's just use R3 here. Let's grab that address. So we're going to grab the address of length, and if you remember, length was the label that marks the end of the array. So if our array pointer is now at that end marker, if those are equivalent, then we're going to reset R2 to be back at the beginning of the array. I forgot an EQ here. So I did a load conditional. So if R2 has advanced to the point where it's now at the end, then we will set it back to the beginning. Hopefully that makes sense. We're getting close. So I first load up that length address because that tells me where the end is, and then I compare my array pointer with this pointer to the end of the array. If they are equivalent, then I'm going to reset my array pointer to be at the beginning of the array again. So it'll advance 4 bytes at a time, 4 bytes, 4 bytes, 4 bytes. It'll eventually hit length, which is marking the end of the array, and then we will reset it back to the beginning of the array. Load the next array value into a register, which must be the same as the register passed to show bits above. So above we used R1, so we simply are going to grab into R1 whatever that pointer is pointing at right now, which will either have been advancing through the array or be reset back to the beginning. You can, by the way, do an offset, but since we're doing updating indexing, that makes a little bit less sense to do that. So we'll just grab the 32 bits at wherever that pointer is. And then we'll call clear bits. Clear bits. Which at present hasn't been implemented. We'll have to go implement that. It looks like I forgot to put a call to delay in here anyway. Oh, the delay is already being called. Okay, that was a mess. Hopefully we're all still okay. We need to go implement what is remaining in our macros. So hopefully everyone gets number 8. R2 is a pointer into our array, and if we grab the 32 bits that are there, that's the next integer. So that's all this does, is grab the next integer from the array in memory and load that value for the next integer into R1, so that when the program loops back to the main loop, it immediately shows the R1 that we just loaded. Clear bits, and then we also owe it a delay routine. So let's go get clear bits and array. I'm going to cheat, by the way. I have the delay macro from lab 13, so which is going to need an adjustment. So I'm going to do delay first. And then I'm going to hit pause for a second and let you catch up on that. So I only have one register that I'm mucking around with in here, so that's the only one I have to push and pop to make this thing behave more like a high-level function. So I'm going to leave that there for a second. This delay loop value is somewhat arbitrary. You can fiddle around with that value. But since it told me to use the stack, I went ahead and did that with pushing and popping. This time just with the one register. All right. It's going to run a little bit over an hour, but not too much longer. I'm going to go over and do a compile on it real quick. Whew. Still good. Okay, hopefully we're all okay to give me a hit pause if you need a hit pause, or if you need me to go back, just stop me and I'll go back. I'm fine with that, because I need to scroll down and find clear bits. Somewhere down here is clear bits. Okay, so I know which bits I need, so I'm just going to copy this little note to myself. Need to clear them bits. These parts don't have any meaning because I'm not doing a display. I just need to clear out these bits. And I can do this one pretty efficiently because I don't have to do any bit testing. So the first thing I'm going to do is just my bit clearing. So I need to get my GPIO-A output data register and then a value from it. Hopefully this is not too fast. And then I'm just going to bit clear it. In fact, I'm not even going to skip a line. I'm just going to bit clear that thing. I need to target specific bits. So A5, it starts at A5, not A4. So I need A5, A6, A7, A8, A9. So I'm just going to clear them all at once. That is 3, E0. And then store that back. So there's the A's cleared, and then I'm going to do the same thing with the B's, reusing registers. let's see, this is B8, B9, and B10, so all of these I don't need. B8, B9, B10, so that in hex is 7, right? Hopefully that's right. Store it back. Then I'm going to do the stack bit, and then I'm going to hit pause and let everyone catch up. So we've done these operations before. We just haven't done them in precisely this way because now we're sort of separating out into macros, nice clean independent macros. I used R0 and R1, so let's push and pop those. And I'm going to go run the compiler on it and make sure that I didn't make any huge mistakes. So I'll let you catch up here for a minute or two and let me know if you're having issues or what you need to look at, because I may have gone a little fast. So it's perfectly fine. And of course, I don't have another class till 11, so if you are struggling a little bit and you're here, I'm perfectly happy to stick around and help you work out your bugs. I believe that's everything. So my next step is going to be to do the remaining steps in the recipe and see if my circuit works by letting me click through my array 1 through 10 and then back to 1. It would be, it'll feel good. I'm not confident, to be honest. But I'm going to power up and I'm going to go, oops, ground fell out, ground fell out. Maybe I can get that closer for you. How does that look? It's okay. All right, the remaining steps. I'll bring that back. I'm just going to run through elf, bin, burn. So I've already did the compile, and I'm going to do the elf step, maybe. Elf. We're looking for nothing to happen until the burn step when we get the jolly good. Bin. Burn. Looking for jolly good. So far, so good. Alright, so I'm about to reset my board, and what I want to see is the first element of my array, which is 1, show. So black button to reset. 1 is showing, which is a dang miracle. And now when I click the blue button, which you may have to sort of sit on the blue button for just a fraction of a second, it should cycle up to 2. So there was a little lag there, but it did move. Then I'm going to click it again. I should get 3. And I'm clicking, and then there's a lag, and then 3 comes up. Clicking, letting go. There's 4, 5, 6, 7, 8, 9, 10. Now here's the big test. This thing better go back to 1 or we got a problem. Hey! I'm going to do it one more time. 2, 3, 4, 5, 6, 7, 8, 9, 10, back to 1. Um, I hope that you're having something of a similar experience. I'm going to do one more thing while I'm broadcasting, which is I'm going to go fiddle around with my values and put some negatives in there and see what that looks like. Um, so I'll probably like go from, I don't know. All right, so, but I do want you to see, like, remind you where I would go to change the values. So I go back to reset array, and I'm just going to pick. So instead of 1 through 10, oh, yours doesn't increment. Okay. So let's check. So the incrementing stuff starts on element 6. And then if Vince, if you do see where it was at, let me know that you saw it and found an issue to fix. So it starts at number 6. So we look to see if R6 is 1, and R6 being 1 means that the button has been pressed. So that's what the button code does, is it sets that value to 1 if the button has been pressed. And then if that's true that R6 is 1, then we increment the array pointer. So that's where it starts, is on number 6. And just let me know, like, does your number 6 look okay? And then we'll move on to number 7. Like, just give me a 6 okay or something like that. Because someone else, no doubt, will benefit from this if we sort of step through it. Okay. And 8. The trick on 8 is that it has to be R1 here. If it's not R1 there, then clear blitz. Okay, so let's go back up. So what happens then is that it's going to branch to the main loop. So if we go back up, for me it's on line 119, which is roughly where you'll be. It does a show bits in R1, which is the value that we loaded. So is your 5 okay as well then? It's the same value as you did in number 8. So 8 loads into R1, and 5 is show bits on R1. Okay. Um, if you have email, you could email me. Well, you'd have to email me both so I can look. Where else can we look? I mean, I suppose it could be in macros, but that seems unlikely. But maybe you can email me those 2 files, and we can debug it like that while we're here. And anybody else, if it's working for you, let me know. And if it's not, then let's debug and get you fixed. Ah, okay. So Brooksy's was in 4A and 4B. Oh, yeah, that could be an issue. Check that, Vince. When we changed that to R2 and sort of made R2 our permanent array pointer. All right, I got your code, so let me open here. Oh wait, that's macros I opened first. I wanted to open main first. Okay, here we go. Yeah, Vince, yours is the same thing. Um, awesome. Thanks, Brooksy. Very cool. So, what are other folks got going? Working, not working? If yours is working, you should be good to go, and then we'll talk a little bit about, pardon me, what the pushing and popping was doing. Um, I'm gonna go. I'm gonna change my values a little bit. Just put a couple of negatives in here, like negative one, one, negative two, two. I'm gonna put a zero in there. Just nah, zero is boring. So that's my last experiment, is to put some negative values in my reset array. What the negatives should do is show a whole bunch of lights because they're in two's complement. So I'm going to go through my process and see what that looks like. Go back through the, so compile, elf, bin, burn. Really good. So let's see, I started at negative 1. So that's correct, and 2's complement should be all the lights on. Then 1. Then negative 2, which is most of the lights on. Then 2. Then negative 3. Then 3. Then negative 4. Then 4. Then negative 5. And 5. So that was my other little test. You can put whatever values you want. When you submit it, I'll run it and just cycle through. I'll look at what your values are and then cycle through and see if it looks like it's the same values showing. So probably some of you are experiencing some frustrations because I created some confusion, and apologies for that. But we'll get it fixed, and hopefully you'll feel satisfied like I do right now, because that's a complicated lab and it feels good to have it work. Okay, so I'm just going to sit here for a while and field your questions and try to help you debug. Yeah, it's pretty dang satisfying. I hope that you're finding that too, because it's so hard to do. I mean, it seems like it's such a simple thing, but it's quite difficult to pull all that off in pure assembly. So it's pretty badass, I think. Um, yeah, I like it as well. We're going to build on that. So this is building blocks. This is one of the features of our final lab is code that cycles through an array and displays it. So now we have that piece built. So if you're done, then great job. Thanks for bearing with me as I crossed myself up there and then couldn't decide how to handle the problem. Oh, that's interesting. Yeah, we can talk about that. And questions can just come in and I can interrupt myself. So you got into UCSD also? Jeez, that's badass. Um, I mean, it's a growth area, and I suspect that the current situation is only going to lead to even more demand for people doing bioinformatics and computational biology. So the demand's gonna grow and sustain growth for a long time, I suspect. And I don't know if you've been watching, but a lot of the epidemiologists and biologists who have been weighing in on how this situation is being handled are also computer scientists. So a lot of them are using their skills in bioinformatics and computational biology to produce models and to evaluate other people's models, and that's pretty interesting. So I think if that area of subject matter, like medicine and healthcare and biology, which can also extend out into the natural world for animal populations, if those things appeal to you, I think it would be a great line of work to go into. You get to do all the sexy stuff that computer scientists enjoy, which is um, chewing on tons and tons of data and analyzing it and trying to make meaning out of data. And you also get to solve interesting problems in the real world. Although don't put us all under house arrest if you do that, please. um, they're probably going to ban my video for saying that. Um, no, seriously though, I think it's a great line of study to go into. So if it appeals to you, and even if you get into the middle of it and you decide this specific subject matter doesn't interest me as much, the same skills can be applied in other realms. So you can take those same skills into business and psychology, and you would just sort of have to learn what their data and what their terminology are. The That's really awesome. So if you do, I would totally go into it right now. I think there's huge amounts of um, exciting and rewarding work waiting to be done in those areas. Uh, there is Coursera. I mean, I use what's it called? Not Stack Overflow. Stack Share. I think Stack Share maybe has some things. Or does it have learning though? Maybe not. One thing I would So Coursera is good. You kind of just have to look around because it's pretty uneven quality when you go to places like Coursera or Udemy. You can look around. I mean, look at the ratings. They can help a little bit. Um, Kaggle, I like. Um, Top Coder is good just for developing your algorithm skills. Um, Euler Project also good for developing your algorithm skills. Oh, I think you can probably find something from MIT in computational biology or bioinformatics on edX too. Oh, also, there is a professor at Chico State who does it, but that's not where you're going to end up. So um, she won't be any use to you. You're welcome. Hopefully that's of some help, but I can definitely say that there's a lot of exciting work to be done, and I expect that it's going to be a growth industry. So you will have lots of opportunities if you pursue that line of study. How's everyone doing on lab? Is everyone already checked out? What's going on? Um, so I think Brooksy's good to go. Vince, good to go. Yeah, you too, Vince. Just a couple weeks, so hopefully I'll see you again on Tuesday morning when we'll knock out another couple of things and pretty soon to being done. Have a good weekend, Vince. Is Brooksy already gone checked out? Um, Anybody else, by the way? We're just yeah, you too, Brooksy. And thanks for pitching in to help that hunt down that bug. I'm sure that other people, because I was stumbling over that part, um, had a similar bug that you helped them fix. How's everyone else doing? Okay, so everyone else that if you're still working on it, I'm about to sign off so I can rest my voice for my next class. Um, if you get stuck on a bug, though, email it to me and we'll work it through. Um, and the video's here, so I will point out that it is probably a common problem. Uh, Items 4A and 4B, so double check 4A and 4B. It's important that the array address is in R2 because we use that R2 later in the program. Yeah. Uh, okay, so scroll into it, Daisuke. No problem. Okay, does anyone out there need to see anything or have any questions before I sign off for a bit? Nice. Okay, that's good. All right, so everyone have a good weekend. Email me if you get caught on something, and I'll do my best to debug it. Um, anyway, so see you next week. Yes, submit both main.s and macros.s since we need them both to see if your code works. So yes.